They're developing technologies that could change the game, technologies that could address the root causes of these problems and create a better future for all of us. From quantum computing to advanced robotics, from smart materials to artificial intelligence, there are so many exciting developments on the horizon. One area that's particularly exciting is the field of quantum computing. This technology has the potential to solve complex problems that are currently unsolvable, problems that could lead to breakthroughs in fields like medicine and climate science. Imagine being able to simulate the behavior of molecules, creating new materials that could revolutionize the way we live our lives. Imagine being able to create ultra-secure encryption methods that would make our data virtually unhackable. This is the power of quantum computing, and it's an area that's advancing rapidly. Another area that's gaining traction is advanced robotics. We're seeing robots that can perform tasks that were previously thought to be the exclusive domain of humans. From assembly lines to search and rescue missions, robots are changing the way we work and live. And then there's the field of smart materials, materials that can adapt to their environment, materials that can self-heal, materials that can change shape and function on demand. These are just a few examples of the incredible technologies that are being developed, and it's clear that they have the potential to transform our lives. One technology that really stands out is CRISPR gene editing. This technology has the potential to eradicate genetic diseases, diseases that have plagued humanity for centuries. Imagine being able to cure cancer, imagine being able to cure genetic disorders that are currently untreatable. This is the power of CRISPR, and it's an area that's advancing rapidly. The implications are enormous, and it's clear that this technology has the potential to change the face of humanity. Join me as I dive into the world of CRISPR gene editing and try to predict the next big breakthroughs that could change our future. CRISPR gene editing is a revolutionary technology that has been making waves in the fields of genetics and biotechnology. At its core, CRISPR is a powerful tool that allows scientists to edit DNA with unprecedented precision and accuracy. By harnessing the power of CRISPR, researchers can make targeted changes to an organism's genome, opening up new possibilities for treating genetic diseases, improving crop yields, and even resurrecting extinct species. One of the most pressing concerns surrounding CRISPR is the ethical implications of playing with the fundamental building blocks of life. Some worry that the ability to edit genes could lead to unintended consequences, such as the creation of designer babies or the exacerbation of existing social inequalities. Others argue that the potential benefits of CRISPR far outweigh the risks, and that it's our moral obligation to pursue this technology for the betterment of humanity. The debate over CRISPR's ethics is further complicated by the fact that it's still a relatively new and rapidly evolving field. As we continue to push the boundaries of what's possible with gene editing, we're forced to confront difficult questions about what it means to be human, and what kind of world we want to create. This is especially true when it comes to the prospect of editing human embryos, which raises complex questions about identity, free will, and the very nature of humanity itself. Despite these challenges, many experts believe that CRISPR has the potential to revolutionize the way we approach medicine, agriculture, and environmental conservation. By editing genes, we may be able to create new treatments for genetic diseases, develop more resilient and sustainable crops, and even restore damaged ecosystems. The possibilities are endless, and the potential benefits are vast, but only if we're willing to navigate the complex ethical landscape that comes with this powerful technology. CRISPR is already being used in a variety of groundbreaking applications, from treating genetic diseases to developing more efficient biofuels. In the field of medicine, researchers are using CRISPR to develop new treatments for everything from sickle cell anemia to muscular dystrophy. In agriculture, scientists are working to create more resilient and sustainable crops, such as wheat that's resistant to disease and drought. And in environmental conservation, CRISPR is being used to develop new techniques for restoring damaged ecosystems and preserving biodiversity. One of the most promising areas of research involves the use of CRISPR to develop new gene therapies for treating cancer. By editing genes, researchers may be able to create targeted treatments that are more effective and have fewer side effects than traditional chemotherapy. This could be a game changer for cancer patients, who often have to navigate a complex and grueling treatment process. Recently, a team of scientists made a major breakthrough in CRISPR technology that could change the game for gene editing. By developing a new technique that allows for more precise and efficient editing, they've opened up new possibilities for treating genetic diseases and developing new biotechnologies. This breakthrough has the potential to accelerate the pace of research and development, and could potentially lead to new treatments and innovations in the near future. In the future, we can expect to see CRISPR being used in a wide range of applications, from medicine and agriculture to environmental conservation and beyond. As the technology continues to evolve, we'll need to navigate the complex ethical landscape and ensure that we're using this powerful tool responsibly. By striking a balance between innovation and ethics, we can unlock the full potential of CRISPR and create a brighter, more sustainable future for all. Quantum computing is often hailed as a revolutionary technology that could transform various fields, from cryptography to drug discovery. And for good reason, the potential impact of this technology is enormous. It's crucial that we explore its future and the possibilities it holds, and that's exactly what we're going to do today. Currently, quantum computers are still in their infancy, and they're plagued by a multitude of issues. One major limitation is the error rate, which is still far too high for reliable computations. Another challenge is scalability. Most quantum computers are small-scale and can only perform a limited number of operations. And let's not forget the need for more robust qubit designs. The building blocks of quantum computers are still extremely fragile. These challenges are significant, and researchers are working tirelessly to overcome them. But despite these efforts, we still have a long way to go before quantum computers can be widely adopted. For instance, scientists are still struggling to develop a quantum computer that can perform a single calculation without errors. It's a daunting task, but one that's essential for the future of this technology. The need for practical applications is also a major challenge. While quantum computers have the potential to solve complex problems, they're still largely theoretical. We need to develop more practical uses for this technology before it can become mainstream. And finally, the lack of standardization is another hurdle. Different companies and researchers are working on different types of quantum computers, making it difficult to achieve widespread adoption. There have been some impressive advancements in quantum computing lately. For instance, researchers have developed new quantum algorithms that can perform certain calculations much faster than classical computers. We've also seen significant developments in hardware, including the creation of more robust qubits and the development of new types of quantum processors. And let's not forget the major players in the industry who are investing heavily in this technology. One promising area of research is quantum machine learning, which could revolutionize the way we approach complex problems like image recognition and natural language processing. Another exciting development is the creation of quantum-inspired hardware, which can perform certain calculations much faster than classical computers without the need for fragile qubits. These advancements are crucial for the future of quantum computing, and they're bringing us closer to developing a practical, widely adoptable technology. Google, IBM, and Microsoft are just a few of the major companies investing heavily in quantum computing. These companies are working tirelessly to develop more robust qubits, more efficient algorithms, and more practical applications for this technology. And their efforts are paying off. We're seeing rapid progress in this field, and it's an exciting time to be alive. One significant breakthrough that could change the landscape of quantum computing is the development of a topological quantum computer. This type of computer uses exotic particles called anyons, which can store and process quantum information in a much more robust way. If successful, this technology could lead to the creation of a quantum computer that's much more reliable and efficient than current models. The potential impact of this breakthrough is enormous, and it could pave the way for the widespread adoption of quantum computers. Topological quantum computers could revolutionize fields like cryptography and drug discovery. They could also enable the creation of unbreakable encryption methods, which would be a major game changer for cybersecurity. And let's not forget the potential for quantum computers to solve complex problems that are currently unsolvable. This could lead to major breakthroughs in fields like medicine and materials science. So, what does the future hold for quantum computing? Despite the challenges, the progress we're seeing is undeniable. From breakthroughs in quantum algorithms to the development of more robust qubits, we're getting closer to developing a practical, widely adoptable technology.